Serverless processing systems, often associated with Function as a Service (FaaS) offerings, allow developers to execute code in response to events without the need for managing traditional server infrastructure. Here are key concepts and considerations for serverless processing systems. Key concepts. Function as a Service (FaaS). In a serverless system, functions are the units of execution. Developers write individual functions to handle specific tasks, and these functions are executed in response to events. Event-driven architecture. Serverless systems are inherently event-driven. Functions are triggered by events, such as HTTP requests, changes in data, or scheduled intervals. Statelessness. Functions in a serverless environment are stateless, meaning they don't maintain persistent state between executions. State is typically stored in external databases or storage systems. Automatic scaling. Serverless platforms automatically scale functions based on demand. Each function execution is isolated, allowing for independent scaling. Pay-per-use pricing. Serverless platforms typically charge based on the actual usage of resources, such as the number of function invocations and execution time. This pay-per-use model can be cost-effective for certain workloads. No server management. Developers are relieved from the responsibility of managing server infrastructure. Serverless platforms abstract away the underlying infrastructure, allowing developers to focus on writing code. Considerations for serverless processing systems. Cold starts. Cold starts occur when a function is invoked after being idle for a period. It may introduce latency as the platform initializes the execution environment. Strategies like provisioned concurrency or warming can mitigate cold starts. Function size and complexity. Functions should be designed to perform a specific task and kept small and focused. Large functions can result in longer cold start times and may impact performance. State management. Since functions are stateless, external storage systems, databases, or caching mechanisms are used for managing state between function invocations. Integration with external services. Serverless functions often need to interact with external services. Integration points such as API gateways, messaging systems, and databases should be well managed. Security. Implement security best practices, including proper authentication and authorization mechanisms. Serverless platforms often provide identity and access management features. Monitoring and logging. Use monitoring and logging tools to track the performance, errors, and execution metrics of serverless functions. This is essential for troubleshooting and optimizing performance. Vendor lock-in. Consider the potential vendor lock-in associated with serverless platforms. Each provider has its own set of services and limitations. Testing. Develop testing strategies for serverless functions, including unit testing, integration testing, and performance testing. Examples of serverless platforms. AWS Lambda. Amazon Web Services serverless computing platform. Azure Functions. Microsoft Azure's serverless computing offering. Google Cloud Functions. Google Cloud serverless platform. IBM Cloud Functions. IBM Cloud serverless offering. Firebase Functions, a serverless framework by Google, often used for mobile and web applications. Serverless processing systems offer advantages in terms of scalability, cost efficiency, and simplified infrastructure management. However, it's essential to carefully design applications, considering the characteristics and limitations of serverless platforms.